Great. So using operators in Kubernetes for video workloads, kind of a mouthful. So I am Jonathan Fontanez. I founded a company called StreamXR. I'll tell you a little bit more about it and some of the challenges that I had as I go into the talk. But to kind of kick things off, I'm just going to recap what Kubernetes is. This talk doesn't assume that you have intimate knowledge. I'll go through what exactly operators are, and we'll start here with kind of what Kubernetes is. So the simplest way to describe Kubernetes is that it's a management system for containers. If you look up the definition, it's a container orchestration system for automating software deployment, scaling, and management. And what that really comes down to is that you can take containers, which are just lightweight standalone executables. You can put them in Kubernetes. You can schedule replicas for them. You can distribute it across regions. If you are using a cloud provider that has Kubernetes installed, and you can specify different attributes to those containers. And that allows you to do things like configuring networking or other cloud-related systems. To give you an example, you can create DNS entries automatically off of Kubernetes containers. So it gives you a lot of flexibility. And one of the key attributes of it is that everything is declarative. So you're not necessarily having to write code to do all this automation. What you're doing is describing the state of the system that you would like this system to be in. And to kind of get into that, the way it does it is with something called operators. So operators aren't a type of, they aren't specifically like an SDK or anything built into Kubernetes. They are a pattern. And that pattern basically allows you to extend the behavior of Kubernetes. So Kubernetes is divided into clusters. These clusters can span regions, and under those clusters, we have nodes that are basically the machines that are running these containers. And these operators, what they allow you to do is as a pattern, they allow you to basically customize and extend out that Kubernetes. So what it consists of in that pattern is generally it's going to be custom resource definitions. So out of the box, Kubernetes provides you with quite a bit. Just offhand, it gives you things like pods, which are a representation of a container or containers. Gives you deployments and services, which allow you to describe characteristics of those pods or expose it via different networking mechanisms. And there are many different types of resources, but there are times where we want to customize and describe a resource that maybe kind of falls outside of the scope of what Kubernetes provides out the box, or we want it to be very specific to our particular use case. The controllers allow you to actually hook into what Kubernetes calls the reconciler. And that's what this diagram is. It's essentially a control loop. And the best way to describe it is that Kubernetes works on this concept of eventual consistency. So you can think of it like a thermostat. When you go to your thermostat and you specify, you move the dial, or you push the buttons, you're saying that I want the temperature to be, let's say 73 degrees. And what the control loop is doing is it's taking the current states and then looking at the defined state of what you would like for it to be. And it's constantly checking to see, okay, what are the differences between that? And then based on those differences, it's toggling essentially the AC on and off, or in the case of Kubernetes, it's trying to move that system from where it is to the desired state. And as I mentioned, that state is described declaratively. So this control loop is those three parts of that thermostat that I described. You're observing the current state. You are comparing that to the described state and computing a difference, and then you're acting on it. So you are not necessarily doing everything at once, because Kubernetes has this concept of eventual consistency. We're just trying to push it closer and closer to the desired state. So to give you an example of an operator, I'm going to use Prometheus. So Prometheus allows you to gather metrics for your application. If you were to deploy Prometheus just vanilla into Kubernetes, you would likely have a deployment which describes the image that you want to deploy, characteristics about the pods, and ultimately it would get deployed as a pod in Kubernetes. So this is going to be your running application of Prometheus. And then to configure that, you're going to, inside of a config map, tell that pod, okay, I have applications A and B or a set of microservices, and I want to monitor that. And if you can imagine, as your business begins to scale and you say create hundreds of microservices, that config map is growing larger and larger and larger. And that kind of goes against the principle of what we want to do within Kubernetes. We want to declare that, hey, I've got this application and I want you to monitor it. I don't want to worry about modifying a config map. I don't want to deal with kind of configuring Prometheus as if it were a standalone application. I just want you to take care of it as part of your control loop. So where an operator comes in is it's a separate piece of it's a separate, essentially installable that you can take, install into your Kubernetes cluster. And now what you can do is you've got a set of custom resource definitions called service monitors. And you have installed a custom control loop. So this controller into Kubernetes. And what you can begin to do is now you have an application YAML that describes how you want to deploy your application. Right alongside that, you can create a small YAML of about maybe 10, 20 lines, and you can describe, hey, for this service that I'm deploying, monitor it. And what Kubernetes is going to do as part of this operator is it's going to figure out, okay, I've got these new services that came online, they're requesting to be monitored. I'm going to configure Prometheus such that I can now monitor those services, everything can come online. I'm going to handle wiring it. So you've gotten rid of this massive config map in favor of these service monitors that you can deploy alongside your code. And the nice thing about that is that you can check it into GitHub as part of your application. It's very minimalistic, and you can increment it as your application evolves. Or separately, you can remove it if your application is no longer relevant. So how does this all tie in? I mentioned I was going to kind of bring up what StreamXR is, what it does. Specifically, so with StreamXR, the goal of it was to create interactive server-generated 3D content. And that was handled via Unreal. So users could generate content, or content creators could generate Unreal applications. It would be generated on the server, and then that would be distributed out. And it would be distributed via WebRTC. So Unreal provides a plugin called Pixel Streaming. You can add this plugin into your Unreal application, and now you can stream it via WebRTC, and you can connect up as a user or as a player and interact with your Unreal application. And there's real-world examples of this, things like Google Stadia, Xbox Cloud, Amazon has a service called Luna. All these services kind of work off of that principle that basically you are sending content over video with really low latency. Now, there came about a couple of challenges. When you read about the pixel streaming, when you read about the documentation for deploying pixel streaming, it generally kind of talks about these one-to-one deployments, or if you kind of look around, you can find kind of studios that can do, you can find documentation where it tells you, sorry, backing up for a second. These studios or these other providers can, these consultants can come in and get everything set up, but there wasn't really a good way to support for content creators to have a large number of users on a platform. So I wanted a cloud platform as a service that could support hundreds of thousands of users, and you as a content creator didn't have to worry about any of that plumbing. The other goal was that I wanted it to be easily deployable. So I wanted it to be as easy as deploying on an app store. You could, as a content creator, I wanted you to focus on being able to create the content, and then StreamXR would take care of everything else, all the networking, all the plumbing for it, all the scaling out of it, all those things. And finally, I want it to be low latency, and that was another challenge that I had to deal with. So deploying it as close to the end user as possible. And the way that I went about trying to solve those issues was creating a custom auto scaling service. Some characteristics of that auto scaling service were that it was based on virtual machine images. So I was using Google Cloud. I was building out these virtual machine images for Windows. I was having to customize that to ensure that I had the correct NVIDIA drivers, all sorts of things. Once I got to a good point, I could automate that through Packer to build those images. But still, it was a lot of kind of imperative development of that virtual machine where I'm having to maintain scripts and all sorts of things to get the system into the state that I desired. The other thing is I had to build an agent. It's not enough for the operating system to be up or enough for the application to be running. Really, we wanted to what a person would need to know who's monitoring the service is the application actually serving via WebRTC? Is the end user getting a good experience? Finally, another thing that I had to build out in the autoscaler was a way to react to load. And the way that I initially did that was manually scaling up or down. Kind of down the road, relied on cron policies and jobs and configuring essentially a lot of the characteristics that are already provided by Kubernetes out of the box, where you can specify more complex kind of load balancing policies to make sure, or excuse me, scaling up policies. Those things were challenging. It was really hard. And I rejected this solution after months and months of development because I found that I was spending more time building this service than actually focusing on StreamXR. Maintaining this and actually viewing the state of the system and essentially being able to capture every little possible network state that you could get into. I mean, this was a startup in and of itself, is basically what ended up happening. So after a couple months, I just found that this is not sustainable. And yeah, so these were some of the shortcomings. One of the other things that I kind of found that was interesting was that there was no built-in reconciler or control loop. So this was kind of a big thing. Talked about that eventual consistency. One thing, if you're building an autoscaler, is that operating systems do a lot of weird things. You can get weird crashes. You can get applications that require a new version of .NET or any other things that are needed. And there's no way to easily reconcile a system once it drifts away from the ideal state. It's easy to get it spun up, but it's really hard to maintain an application and keep it running. And yeah, as I pointed out, there was a lot of complex logic. So how I went about kind of solving that problem. I extended an operator out there called Agnes. So I started with that as kind of the baseline. This is used in the game industry for launching game servers. So if you've played online multiplayer games, there's possibility that you've used this in the background and didn't even know it. And so I deployed an Agnes instance into a namespace in Kubernetes, which is just kind of like a isolated workspace for applications. I customized the operator with the logic that I wanted. And the way it works is I was able to declaratively state that I want a fleet of these applications. So in the case of some content creator generating a new Unreal application, I define a fleet. And then I tell Kubernetes basically, go handle that. I don't want to think about it. That fleet also gave me the capability to have webhooks to define some advanced characteristics. So I wanted to be able to place it as close to a user as possible. I wanted to, for certain applications, use more GPU processing power, CPU, or memory. For others, if I knew that they were lightweight, I didn't need to allocate that because over allocation meant that I was spending more money per game server. And what Agnes would do is essentially it would deploy this fleet as a set of game servers. And within those game servers, there's actually logic that's reporting back how that application is running. So this goes into that bit where I was talking about that it's not enough to just spin up a virtual machine like I was doing, but you want to know what kind of that internal state is. And what ends up happening is that because of this custom operator, if that game server suddenly is unreliably serving traffic or it's dropping a lot of frames, I can kick out that game server and reconnect a player to a new game server instance. So the characteristics that I was afforded were locality, durability, and reliability. So I could place it close. I had that locality aspect where I can place it close. It was durable because I could essentially kick off new instances if needed. If I saw that there are traffic characteristics where I predicted that I needed a lot more servers, game server instances running. And it was significantly more reliable because I got that in-application monitoring and I could really report down internally in the app if it was actually functioning properly. So how do we take all of that and apply it to video workloads, since that's kind of the purpose of this talk? So what Kubernetes and custom operators, so this is kind of like the magical part for video. Having worked in kind of the event space and with different studios, I realized that a lot of the existing processes for producing video, for transmitting video, are still kind of what I would equate to kind of like the early 2000s way of kind of building applications where companies were managing their own data center infrastructures. With Kubernetes and custom operators, what we can begin to do is we can virtualize hardware that we never thought was possible. So you can take things like lighting, camera, studio equipment like switchers. We can begin to virtualize that because we can represent it in Kubernetes as a custom resource, and we can do something like create a claim on it. And because of that eventual consistency in that control loop, we're constantly checking in to see that, hey, this person wants to use this camera. Can we allocate the equipment to it? And can we wire it into some sort of process or forward it along to applications? So can we wire it up and do everything that's needed in a declarative manner? So an interesting use case for that would be that we have inputs from a camera and we want to perform some set of operations, and then we want to output it. And keep in mind that I want to define all of this pipeline in a simple YAML. So if I were building a custom operator for this particular use case, I would define a new custom resource called a pipeline, and I wouldn't specify anything about the wiring up of things. What I would tell it is that, hey, I want these resources. I want 2 IP cameras. I want to run these applications that I've pre-built or that are from a marketplace. I want to use an effects filter. Like I want to do something that is equivalent to like Snapchat. And then I want to take those frames that are rendered and pass it to this other application, which is doing vision or AI, let's say, analysis to make sure that we have no content that is inappropriate. And then finally, I want to route all of that to a specific RTMP output. So maybe you want to stream this to Facebook Live or Twitch or something else. Normally, this would require setting up a bunch of applications. If you were doing this in the cloud, you may create possibly an EC2 instance, and you've got to plug in the configuration values for the IP camera, all that stuff. And as I mentioned before, if we virtualize the equipment and allow people to lay claims on it as a resource type, we can now wire all this stuff up, and the custom operator basically would take care of everything for you. So it would pull all these resources together, merge everything that's needed, and then you're not having to worry about any of this. You're spending more time building the application, like these cool effects filter or some other thing. Now, this all sounds magical, but it does come with a couple caveats. So operators should never be a first choice. Operators are extremely powerful, and with anything extremely powerful, that generally is going to mean that it can be complex. So really, the advice that I would give is that if you can get away with it, start with using a stateful set, pods, any other Kubernetes provided resources first, especially while you're kind of building things out. And then if you see that there's a use case for an operator, first start by looking at a place like operatorhub.io, which has a lot of great operators that have been built by the community. Those operators are a good starting place. But if you still can't find what you're looking for, a lot of those, if there's a operator that's really close to what you're looking for, you can try customizing that, or you can try building it from scratch. And there are frameworks out there that will help you out. So I would recommend using a scaffolding framework like Cube Builder. It is a Golang specific scaffolding framework, but there are others out there that can help you out, get started, and build out all of these custom resources and defining your controller. The other major thing is this eventual consistency requires a lot of getting used to. So in software development, it's easy to think of, okay, let's say, for example, the thermostat. I may want to do all of the configuration at once that's needed, but instead I'm going to toggle the system off and on. With eventual consistency, what you really want to do is each time that control loop executes, just push it a little bit further, a little bit further. And what that'll allow you to do is more easily test the code. And also you won't have a number of state changes occurring at one time that could potentially break or kind of put your system into a bad state. So avoid the all or nothing when possible, and eventual consistency will kind of get you there. Okay. And yeah, for follow-up, so that's kind of everything in that talk. Tried to fit everything into 20 minutes. Let me see my timer, a little bit over. But if you have any additional questions, here is my email. Anything, questions, follow-up, comments, things that maybe I got wrong, whatever have you, feel free to reach out to me. I also RSVP'd on the meetup, so you can find me there. But yeah, I don't know if we're doing any sort of questions now or afterwards, but that is my talk.